Welcome to Physics with Mr. Brazil. We're looking at gravitational force between three masses. What is the gravitational force that the 3 kilogram mass experience due to the other two masses? In other words, let's look at these masses as if they're pinned in space. And if we were to unpin the 3 kilograms, where would it go? Which way would it move? And what total force does it experience? So, to do this, we're going to take the net force on the 3 kilograms, and if I were to let that 3 kilogram mass go, due to the 4 kilogram mass, it would move to the left. So this would be a negative gravitational force, and let's make this 3, 4. So signifying the masses. Now, let's stop and look now at the 5 kilograms. So what's going to happen if I unpin the 3 kilogram mass, and where will it drift? Well, it will drift a positive force to the right, gravitational force 3, 5. Okay, now let's set up our equation. It's going to be minus g, the mass of the 3, the mass of the 4, the distance, I'm going to call it R3, the 3 meters, squared, plus g, mass of the 3, times the mass of the 5, and this will be, and I'll call it R4 for that distance, squared. Okay, now I'm going to factor out g, the 6, and I'm going to 6.67 times 10 to the negative 11 newtons, meters squared, kilograms squared. We'll make this a bracket. So 3.0 kilograms times 4.0 kilograms, all over 3.0 meters squared. And if you ever have different distances, make sure you convert them to meters and make sure you convert the mass to kilograms. And let's put the minus, plus, now we're going to have the 3.0 kilograms times the 5.0 kilograms all over the 4.0 meters squared, bracket, and this is going to equal a negative 2.6 times 10 to the negative 11 newtons. So the overall force is 2.6 times 10 to the negative 11, but it's going to be to the left because of the negative sign. So if we were to unpin this 3, it would drift a little more it would drift towards the 4. Okay, again, this has to do with the R squared rule. Okay, 4 is 16, dividing 16, it's a bigger number, it's going to make things smaller. Now, let's take a look, and let's say we're looking at the 5, and we're going to unpin that and pin the 4 and the 3. And what will happen here? Well, I'm going to make this a little smaller so we have some room. So let me do that. Let's make this a little smaller. Okay. I could probably move it like that. All right. Get my pen back. And let's do this in a different color. How about blue? All right, so in this case, we'll look at the 5. And if we were to unpin the 5, it would drift to the left due to the 3. So force of gravity, 3, let's be consistent, 5, 3. Now due to the 4, minus 4g, 5, 4, okay? So I'm not going to write the number for g. I'm just going to factor out also the negative. So g, parenthesis. So this will be m5 times the 3 all over, in this case, this is going to be r4 squared, plus m5 times, oops, I don't even need the parenthesis, m4, but this time around, this is going to be r4, 3 plus the 5 distance, so that you get that in your mind, okay? Because it is 7 meters away, the 4 and the 5 from each other. All right, so let's put these values in together. I'm going to keep the g for space, so 5.0 kilograms times 3.0 kilograms all over 4.0 meters squared plus 5.0 kilogram times 4.0 kilograms all over parenthesis, and I'm writing it out so that you see it, 3.0 meters plus the 4.0 meters squared. That's where I got the 7 earlier. Well, we plug this all into a calculator. You're going to get 8.98 times 10 to the negative 11 newtons, but sig figs, and so we're 2 sig figs, the actual answer will be 9.0 times 10 to the negative 11 newtons. Okay, so here's our 2 answers. We could do the same thing for the 4, but I'm just going to show you for these 2 particles. Okay, there's another video. It'll be with component vectors, so therefore there's going to be angles. So watch for that one. Keep practicing physics. Bye.